Hello! That was loud. We're going to talk about reversing probabilities, and what we mean by that is reversing conditional probabilities. So we talked about the probability of A given B, and now we're going to talk about the probability B given A. And what confuses some people is that they're not equal to each other. Probability of A given B usually does not equal the probability of B given A. The probability of A given B is not 1 minus the probability of B given A. There's no direct relationship between them. If you knew one of these, doesn't mean you know the other one. And some books make a big deal of it, but it's not that fancy a concept. They're just different animals. This is knowing B was the probability of A, knowing A was the probability of B. The important thing to remember, though, is you want to know what you're conditioning on. You condition on what you think is true. So you want to remember what you're conditioning on and see if that makes sense for whatever problem you're working on. Now, a famous example of knowing what to condition on is from the drug testing literature. We wrote a textbook a long time ago, never got published, but the name of the section was You're In or You're Out. And if you say that out loud and think about it, it has to do with drug testing. Suppose you're at a plumbing company and you want to drug test your employees. In fact, you're going to have a really strong policy that says if your employees test positive for drugs just once, you're going to fire them because you don't want these employees on your payroll. Well, suppose you go online and you find these tests, and this is a pretty cheap test. This is a P strip test. It's 98% accurate. What does that mean? It actually means this. Many people don't realize what it means to be 98% accurate. Well, if you're a drug user, the probability to test positive is 98%. Now, that sounds nice until you think about it for about 5 seconds. If you're a drug user, the probability to test positive is 98%. But what's going to happen in practice? In practice, someone's going to pee on the strip, and the strip's going to say positive, and you want to know the probability they're a drug user. You actually want to know the reverse of this probability. Well, that's curious. You don't want to know this. You want to know the reverse probability. You condition on what you know. Someone pees on a strip, it tests positive. You want to know, given the test is positive, what's the probability they're a drug user? Well, just because A given B is near 100%, or high, as you might say, bad pun, doesn't imply B given A has to be high. You just got to run the numbers and run the formulas. And so people don't understand that, but just because given you're a druggie that probably tests positive 98% doesn't mean that the reverse has to be 98%. It could be a lot lower. Just have to run the numbers and see what it means. So that's counterintuitive to some people, but it has to do with you condition on what you know. And if I know that strip is a positive test, then I want to find out the probability that the person in front of me is actually a drug user. Well, let's set this up mathematically. To set it up mathematically, we need a little more information. So we're going to get this. If you're a non-drug user, the probability to test negative is 90%. And that makes sense. You want to be ferreted out as a non-drug user. So we have this. And now we need the overall incidence. So let's assume that 10% of the employees are the drug users. I put myself to sleep. Okay, wake up, Mike. There, wake up. So we know some conditional information. We know 10% of Rapid Rooter employees are drug users. We can do the 2x2 table trick to get the entire table. So what are we doing here? We're told drug users 10%, non-drug users 98%. Where did this come from? Well, we know the probability that you are a test positive, given you're a drug user, times the probability you're a drug user. So that's what this thing is. Given you're a drug user, the probability you test positive is 98% times 0.1, so 0.098. We get this thing by subtraction, because that's add up 0.1. This is the same idea, except we're looking at test negative and non-drug users, and then we get this number by subtraction. And we add up, we get the marginals, and we get everything we want in the table. So pause here, make sure you can create that table. Very useful skill to be able to create that table. Once we have the table, we can easily calculate this conditional probability. It's going to be the joint probability on top, the probability of drug user and test positive, divided by the probability you test positive. You go through the numbers, it turns out to be 52%. So given you test positive, the probability your drug user is 52%. What's the interpretation's probability? Well, a lot of people are going to be called drug users who actually aren't drug users. And what if your system says, Well, you test positive once, we're going to fire you. There are a lot of people going to be wrongfully terminated. Will the lawyers be happy? Not the lawyers for the company. But I think the lawyers for the employees that get wrongfully terminated will be happy. Because again, it's not that accurate a test. Given you test positive, you pee on the strip, you test positive, the probability you really are a drug user is only 52%. Well, what do people do in practice? They don't use really cheap tests for one thing. This test was what, $1.90, down to 88 cents in bulk. Maybe have someone do this test 5 times in a row. See if they're positive each time. That would actually mean something. You calculate the probability of that, and that would increase the chances of really only finding true drug users. Or there are much more expensive tests out there that have better properties. But again, the big underlying idea is you condition on what you know. The other thing you want to be able to do at this point of the game is, given this and a little bit of information, other information, of course, you want to be able to reverse that probability. So I hope this was useful. Again, looking forward to seeing everyone in class, and I hope you're having a great day right now.